These PhET simulations do a really good job of illustrating plate tectonics and how it really works. So let's go through some scenarios on here. First with convergence, if we're talking about converging plates, let's put a continental crust here and an oceanic crust here and watch them converge. Push this way, so we're going to see what happens. You can see that the heavy oceanic crust is subducting underneath. The continental plate is taking with it water, and we can see this water as it's moving down, it's heating up, and it's heating up the mantle around it. The steam is rising, and it's going to start pushing upward because heat rises. Now watch up here, we've got time elapse. It's only been 20 million years. We don't have much going on above ground yet, but if we keep going, if time keeps passing on, here we go. More heat rising, we have a volcanic mountain range forming. We have stratovolcanoes forming along the coast. We have a trench forming at the margin of these two plates. We'll let it go all the way. We've got 50 million years. We have a trench. We have a volcanic mountain range, all because of this subduction event. Let's try two oceanic plates. Let's see what they do when they subduct. I already gave it away. Let's see what they do when they converge. Well, the old plate is going underneath. It's heavier. So we're getting a trench. We're getting subduction. And you guessed it, probably there's water going down with this plate. That water is going to heat up. There it goes. We got steam rising. It's going to start pushing upward, and what are we going to get? We're at 30 million years, starting to rise up. We have a volcanic mountain range. There we go. Another instance of conversion. So we've shown continental with oceanic, oceanic with oceanic. Let's do continental with continental and see what happens when they converge. Alright, they're folding upward. You can see as they push inward, they're folding up, and we have a folded mountain range. Alright, that's conversion. How about diversion? What if we have two continental plates diverging? Let's see what happens. There they go. A million years have passed. We've got a rift valley. And you can, as they don't show the convection currents, but this convection current is going to be going clockwise. This one's going to be going counterclockwise, moving these plates apart from one another, fitting this lithospheric plate up here. Magma is going to start pushing upward. So not only do we have this rift valley from the separation, but we have new land forming in the middle. All of this land in here is new, formed from this magma that's coming up from the thinning lithospheric plates. So you can see two continents pushing away. This is happening with South America and Africa. It's happening with North America and Europe. They're moving apart. How about two oceanic plates diverging? Once again, let's put this on automatic. So we've got convection currents moving this direction, scraping underneath the plate, moving it counterclockwise over here, scraping underneath the plate. We have magma coming up at this point where it's thinned out, and we have a mid-ocean ridge. We have an oceanic ridge running up this margin. This is happening in the Atlantic Ocean, as we said before, with North America going one way, Europe going the other, and a ridge going all the way up the length of the Atlantic Ocean, all the way up to Iceland. So, I think a really good illustration of plate tectonics for you.